how we will solve a integration of this kind. So this is the integration 0 to 2 pi, so which is a function of sine theta comma cos theta into d theta. If I have a function of sine theta and cos theta, now how we will solve this integration? So basically we will solve this integration around a unit circle. For example, I will take the first question. So a value 8, the integration 0 to pi, 0 to pi a into d theta over a square plus sine square theta, and where a is some value greater than 0. So I take it as integration I, this values. Solution. Now, first we know that the value of sine square theta. So what is the value of sine square theta? So this is equal to 1 minus cos of 2 theta by 2. So just substitute this value, I get I. This is equal to integration 0 to 1 a d theta over a square plus 1 minus cos 2 theta over 2. This values. Now this value is equal to integration 0 to 1. So this is a 2a d theta over 1 plus 2a square, 1 plus 2a square into minus of cos of 2 theta. So this integration is 0 to pi. If this integration is 0 to pi, to complete a circle, I will change the limit from pi to 2 pi by substituting the value of 2 theta equal to t, right? So put 2 theta which is equal to t, then it means 2 into d theta which is equal to dt. Now from this, theta is from 0 to pi, then what is 2 theta? So 2 theta is 2, 0 means 0 to 2 pi, so it completes the circle. So what is 2 theta which is equal to t? So what is limit t which is from 0 to 2 pi? Now substitute this value, then the integration I will become I, which is equal to 0 to 2 pi, first this values, and second is what is the value of 2a d theta, this is a dt, so this value is a into dt over, what is this value? This is 1 plus 2a square minus cos of t. Now this is a function of cos theta या cos angle या sin angle, and its limit from 0 to 2 pi. Now it satisfies the condition of unit circle. Now what is the unit circle? If I take t as a unit circle, so what is the t? T is equal to e raised to power, because theta is already used, so we can use some another value, e raised to power I am taking iota phi. So what it means? It means modulus of t which is equal to 1, this values. Now the function is in term of t, so modulus of t which is equal to 1. Now what is this modulus of t? So this is a simple contour C. So this is a simple contour C, this values whose origin is O and radius is 1. So this is denoted as C. So what is C? C is modulus of t equal to 1, right? So it means 1 by t which is equal to e raised to power minus iota phi. Now from these two equations we can get the value of cos phi as well as sin phi. But here I need a cos of t, the cos of t. So just my requirement is cos of t. So here I used not phi, here I used t. So here some complex number that may be any number. So just change that values. So understand the basic concept. So I used this values. Now this value is iota raised to power t. So I am already used Z. So I am already used Z. So I take Z is equal to e raised to power iota t. Now it implies modulus of Z is equal to 1. So it means it is a contour C whose center is 0 and radius is 1. So what is 1 by Z? So 1 by Z is e raised to power minus iota t. Now understand this values. From this we can find the value of t. So when we take Z plus 1 by Z, so this will be 2 times cos of t. From this v value at Z minus 1 by Z, which is equal to 2 iota sine of t, this values. So what is the value of cos of t? So this is equal to 1 by 2 into Z plus 1 by Z, this values. And what is sine of t? Sine of t 1 by 2 iota into Z minus 1 by Z, right? And similarly, from this, what is d of Z? So d of Z is e raised to power iota t into iota dt. So there we get the dt which is equal to 1 by iota z into dz. So this values. Now I get the value of dt. I get the value of cos of t. Now here integration will become I. This values. Now this is integration around a unit circle C. So what is A into dt? So dt is 1 by iota z into dz, right? This value is over. Now substitute the value of other 1 plus 2a square minus cos of t, right? So 1 plus 2a square minus cos of t. So what is the cos of t? Which is equal to 1 by 2 into z plus 1 by z, this values. Now simplify this integration. So simplify this integration. We get this is minus minus a iota into dz. So this is upper part, and this is also with the 2. So this is 2. Z is cancelled with this. So here it is z square, or here 1 plus 2a square into 2z. So 2z, this is 2z, and minus this value is equal to z square plus 1, this value. Now if we multiply by minus, this is minus term, so if we multiply by this term, so this will become integration c 2a iota into dz over this values. So this is a z square, then minus 4a square plus 2 into z, this 2 is multiplied by this, plus 1. So I get this integration 2a iota, this values, plus 2 time, also write it as 2 time, or simply in this way. Now here my integration is I, which is equal to, here it is my integration, so 2a iota integration c, and this value is dz over this value z square minus 2 into 1 plus 2a square into z plus 1. So where c is the unit circle, c is the unit circle. So this is c, and this c whose origin is 0 and radius is 1. So this is a c which is a modulus of z equal to 1. Now it is a quadratic equation, it has two roots. So here we can apply the residue theorems. So just check that. So this is a, we can apply the residue theorem. If I write this I integration, this is equal to 2a iota integration of c phi of z into dz. So what is phi of z? Phi of z is a function whose roots are 1 over z square minus 2 into 1 plus 2a square into z plus 1, and this has two root. One root is alpha and second root is beta. So we will find the root of this equation, then we will apply the residue theorem to this integration. Now this integration is noted as equation number 1. Now how we will solve this integration? Basically, now I am trying to solve this integration by using the Cauchy residue theorems. So this is my function. So first find the pole. So poles of function fz are given by pole of the function is given by z square minus 2 into 1 plus 2a square plus 1 equal to 0. So it is a quadratic equation, has two roots. So what are the two roots? Z, which is equal to 2 into 1 plus 2a square plus minus 4 1 plus 2a square raised to power 2 minus 4 and square root over 2 this values. So this 4 is common, so we can take an outside. So what we get? We get 1 plus 2a square, it is from first part, and plus minus, so this value is equal to square root of 1 plus 4a square, 4a 4a square minus 1. This cancel with this. So this is a equal to this values 1 plus 2a square plus 2 is outside, and here a is outside, a square, and remaining part is which is equal to 1 plus a square square root, a square plus 1, this is square root. Now it has two root with plus and one is minus. So let I take alpha, which is equal to 1 plus 2a square plus 2a into square root of 1 plus a square, and second is beta 1 plus 2a square minus 2a square root of 1 plus a square. So these are the two root of the function phi z. So alpha, beta, these are simple pole of function phi z. So this is we are talking about phi z. So simple pole of function phi z. So phi z is basically 1 by z minus alpha, 1 by z minus beta. So this way. Now, what is the given part? So now my aim is to check that which pole is inside the circle. So this is a circle, origin radius 1. So my aim is to check that alpha, and from alpha and beta, which number lies inside the circle. Now clearly alpha a is greater than 0, that is by question. So clearly it's a very important concept. Clearly a is greater than 0. So if a is greater than 0, so from this it means this is positive, this is positive. So this term is positive, right? And this term is positive, and this is a 1. So all the yellow part is positive. So this is 1. So it means modulus of alpha is greater than 1. Clearly, its absolute value greater than 1. And from this check, so this is a less than 1, and modulus of beta, which is less than 1. This values. So it means this is a pole which lie inside the circle, and alpha is a pole which lies outside the circle. So it implies Z is equal to beta is a pole of phi z which lies inside the circle C, which lies inside the circle C. So it means this is some beta and this is alpha. So my aim is to find the, if I apply the residue theorems, So what is the residue theorem? So integration of phi z into dz around C, which is equal to 2 pi iota residue of function phi z at the point z is equal to beta. So this is my A. Write it as equation number 2. Now what is phi z? Phi z is equal to 1 over z minus alpha into z minus beta. So what is the phi z? So phi z is, if I write it in this way, so this is a 1 over z minus alpha into z minus beta. So what is the residue? So residue of function phi z at the point z is equal to beta. So this is equal to limit z approaches beta, and this cancel over 1 over z minus alpha. So this is a 1 over beta minus alpha. So this is a beta minus alpha. So simply substitute the value of beta and alpha that we have given. So this value is equal to, by substituting, so this is minus 1 by 4a into square root of a square plus 1. So this is a value of residue of phi z with at the point z equal to beta. Now what is the integrations? So integration of phi z, integration of phi z around the C, which is equal to 2 pi iota into minus 1 by 4a into square root of a square plus 1. Now substitute in this values, then we get the value of integration I. So what is I? I is equal to 2a iota integration of C phi z into dz. So just substitute this values. So what we get? We get 2a iota bracket minus this values 2 iota minus 2 pi iota over 4a into square root of a square plus 1. This values. Now this 2 into 2, 4. This cancel with this term, and this a is cancel with this term. This is iota into iota, iota square minus iota square is positive number. So we get, this is from this I get pi positive square root of 1 plus a square, ja a square minus plus 1. So this is the answer of this result. So in this way we can use the residue theorem to find the question of this kind. So basically it is the integration around the unit circle. So in this way we can find the integration around the unit circle if the given function is in term of sine and cos theta. So we find in this way. Now question number, second question of this type, again it is very important. So what is prove that? So what is the statement of the question? Prove that 0 to 2 pi, this is the integration, 0 to 2 pi e raised to power cos of theta into cos of n theta minus sin theta and into d theta this value is equal to 2 pi by n factorial. So prove that left hand side is equal to right hand side, right? Now here see that our question is of this kind. Integration is from 0 to 2 pi. Also it is a function of sine theta and cos theta. So we will apply the integration around a unit circle. So let I take this C, which is a unit circle modulus of Z equal to 1. So what it means? It means Z is equal to e raised to power iota theta and dz is equal to e raised to power iota theta iota into d theta. So this can be written as d theta is equal to dz by iota z. This is one thing. Second, 1 by z can be written as e raised to power minus iota theta, so which is cos theta minus iota sine theta. So from this we get the value of cos theta, which is 1 by 2 z plus 1 by z, and similarly sine theta, which is 1 by 2 iota into z minus 1 by z. This values, right? Now see the our question. So this is the basic part, and if C is contour of unit circle, so basically C is a circle of radius of 1. So no problem. This is a basic origin. So this is a radius 1. So this is a C contour of this value. Now what is my function? So what is function? So this is a given integration. So which is from 0 to 2 pi, 0 to 2 pi, and second is e raised to power cos theta and cos of n theta minus sine of theta into d theta, this values. Now what is this? It is a real part. So cos of n theta minus this. So it is a real part of the cis form. So cis form of n theta minus sine theta. So it is a real part of that cis form. So what is this? It is a cos n theta minus sine n theta, right? So if cos n theta minus sine n theta, so this is a real part of this values. So this is a remainder. This is a r. So first see what is this kind of question. So this is a cos of n theta minus, so I take it as angle. So this is a angle. So if it is an angle, so this integration I, so which is equal to, so what we, so this is a real part of, this is a real part of integration 0 to 2 pi. So this is second 0 to 2 pi e raised to power cos theta, e raised to power cos theta, and here e raised to power iota, which is equal to n theta minus sine of theta and into d of theta. This is it. So it's a real part because this can be written as cos of n theta minus sine theta plus iota times sine of n theta minus iota sine n theta. If here the term was sine of this, then it will be the imaginary part. Now I am taking, it is the real part of this kind. So this is a real part of this functions. Now, if I solve this integration, if I find the value of this integration, then I will find the value of I by taking its only real part. So, in order to find this kind of, now what is this? This is a e raised to power iota n theta minus iota sine theta, this values, and this is cos of theta, right? So this values. Now just see this values. Now this integration, I simplify this integration, which is a real part of, real part of, this is integration 0 to 2 pi. So what is this integration? E raised to power cos theta, this is a cos theta minus, here it is cos theta, minus iota sine theta, this cos theta minus iota sine theta, and e raised to power iota n theta. So I am taking because this type in the form of z. So what is z? Z is equal to e raised to power iota theta. So I am forming in this way. So basically it is a 1 by z. So this term is 1 by z. So this is a cos theta minus e raised to power iota sine theta. This values, and this is a iota n theta. So this value is, now this equation cos of theta minus iota sine theta, if I am taking in the cis form, so basically it is a 0 to 2 pi e raised to power, and this is e raised to power minus iota theta. It's nothing. It is e raised to power minus iota theta, because it is cos theta minus sine theta. So this can be written as of this form. And what is this? And this is e raised to power iota theta raised to power n. So this values into d of theta. Now I convert this integration into complex form. So this integration will be converted into, if I take that integration as I, so in the complex form, this is integration 0 contour C, and this is E and raised to power. This is E raised to power minus E raised to power minus iota theta. So this is a, if E raised to power, if this value is Z, E raised to power iota theta is Z. So this is E raised to power 1 by Z. I write it in this way. And this is Z raised to power N. And what is the d theta? D theta is a dz over iota z. So this is my way to express in this form. This is the first way. Also, I write it as, if I write in this way, so this is of e raised to power 1 by z, and this is here z raised to power n minus 1, and this is, so z equal to 0 is the singular point. So and e raised to power 1 by z, and here it is a z raised to power n. Now this integration I write it as e raised to power 1 by z over z raised to power n minus z raised to power 1 minus n minus 1. So here I can take here z raised to power n minus 1 into dz, this value around C, and this is a 1 by iota. So this is outside. Now this function has singular point z equal to 0. So this point has singular point z is equal to 0. So my aim is to find the residue to find this integration. This is a function. What is the function? Function is e raised to power 1 by z into z raised to power n minus 1. If I used z raised to power n minus 1 and by series expansion exponential 1 plus 1 by z plus 1 by 2 factorial 1 by z square continue and so on 1 by n plus 1 factorial n plus 1 factorial 1 by z raised to power n plus 1 and the previous term is 1 by n factorial 1 by z raised to power n plus so on up to infinity. So what is the residue of this function if I take this function as phi z, this values? So z equal to 0 is the singular point. So here z is equal to 0, which is a singular point of a function of a function phi z of a function phi z. So what is the residue? So residue of phi z around z equal to 0. So this is a only singular point function of phi z inside C. So only then it is only 1. So what is the residue? So residue of a function is coefficient of 1 by z. So when we multiply by this term with this term, so we get the coefficient of 1 by z. Because it is z raised to power n minus 1, it is z raised to power n. So what is its residue? So this is equal to 1 by n factorial. So here we find the value of this and also it is 1 by iota. So if it is 1 by iota, so this can be written, but 1 by iota z. So this can be written as this integration I, which is equal to 1 by iota. So I integration, which is equal to 1 by iota into 1 by n factorial, this values. So this is residue and 1 by iota into n factorial into multiply by 2 pi iota into multiply by 2 pi iota. So this is a integration of this values 1 by iota and this is 2 pi iota. So this 2 pi iota 1 by iota into 2 pi iota into n factorial. So this integration, so this will be, this 2 iota is cancelled with this. So this value is 2 pi by n factorial. So this is a value of 2 pi by n factorial. Now this is the value of our integration. Now substitute what is I? I is the real part of this integration. So what is the I? So I is real part of this integration 2 pi by n factorials. So what is its real part, which is 2 pi by n factorial. So this is the real part. So I integration, which is equal to 2 pi by n factorial, which is our result, which is right hand side. So which prove our result. So in this way, we can find the value of this equation. On similarly line of action, do the question, prove that. So prove that on same line of action. So prove that integration 0 to 2 pi, which is e raised to power minus cos of n theta plus sin theta into d theta, which is equal to 2 pi minus 1 by n over n factorial. So this is our next question, where n is positive integer. So this is very important type. So do it yourself on same by using the same method that we used in this part. So this method was, what is this method? So this method was to find the integration around a unit circle. So this method was integration around a unit circle, around a unit circle. So in this case, what is the given? Given is integration 0 to 2 pi, this values, and function f is a function of sine theta, cos theta into d theta, right? And what we will do to solve this integration? We will take z is equal to e raised to power iota theta because it is a unit circle. So modulus of z equal to 1. Similarly, 1 by z is equal to e raised to power minus iota theta. From these two equations, we get the value of cos theta, which is equal to 2 cos theta equal to, and similarly, we get the value of sine theta, and we get the value of d theta, which is equal to dz by iota z. So using the same method to all questions, so we will find the integration around the unit circle. So in the next type, we will discuss the next type. So this is my first part, and also in the next type we will discuss the number of poles of fz lies in real line. So we will discuss the poles lies on a real line. So we will discuss the integration of a whose has pole just singularity on a real line.